What's up guys, Dylan Codes here, and welcome to Christmas Eve, day 24 of Advent of Code 2020. Man, it's been a quick December, so if you like this video, please go ahead and drop a like, and let's go ahead and get into day 24. Alright, what do we got? Lobby layout. Your raft makes it to the tropical island, but it turns out that the small crab was an excellent navigator. They've brought a new tile floor where the tiles are hexagonal and will need to be arranged into a hex grid with a very specific color pattern. So white and black tiles. The list of tiles needs to be flipped over, given some directions from a reference tile. A tile is identified by a series of these directions. Okay. So how many are flipped to black? And I think if they all start as white. Let's go ahead and get our input. Paste that in there and get into it. So say with open input 24.txt as file data is equal to file.read lines. Data is equal to line.strip, a list of line.strip for line in data. And I think with that, we can go ahead and get into it. So, we are going to write a function called parse. And here, I'm just gonna copy this random line here, and we are going to have to parse out this line. So parse, and we will take a line, and we're going to create a list called dirs. So for, I think we'll say for, let's do this. While length of line is greater than 0, if, and we can say if line 0 in, because basically we're going to have either northeast, southeast, northwest, southwest, west, or east. So if it's west or east, so if line in west or east, then dirs.append line 0, and then and then we can say line is equal to line 1. So basically every time we're going to be, so first we take off west and then everything after west. Else, now, we're never going to have just plain north or south, so we know if north or south is the first, then guaranteed we're going to also take the second character. Else, dirs.append line, and we will take everything up to number 2. So we want 0 and 1, and then line is equal to line everything from 2 onward. Okay, and then return dirs. So now if we go ahead and run this, we can say lines is equal to a list of parse line for line in data, and then we can go ahead and print this. For L in lines, print L, and what does that give us? Okay, so you can see that is split up our lines into directions. Perfect. So now what we need to do is write a loop for line in lines. And so basically it's going to start from a reference point. And if we look at like this hex tiling here, maybe this will give us a clue. So we're going to have a couple of directions that we can go. We're going to have kind of this east-west direction. And there, or I guess, I don't really know. You have like northeast and southwest, and then you have northwest and southeast, and then there's also east to west. So I think what we're going to do is, I think if we assign, let's see, so we are going to say that, so we're going to have some point x, y, z, and the center is at 0, 0, 0. Now, if we move east and west, then that is in the x, we'll call that in the xy plane, And then northeast, or okay, northwest and southeast, we can call that in the, let's call that the xz plane. So it's like kind of having like a coordinate system where instead of just having x and y, we're gonna have kind of like x, y, and z, if that makes sense. Instead of having 2 axes, we have 3 axes. So, and then northeast and southwest will be in the YZ plane. Okay, or I guess the YZ axis. So now let's go ahead and write this. So we'll say for direction in line, if dir is equal to west, well, okay, we'll say, first we ought to say for line in, or no, what am I to? X, Y, Z is equal to 0, 0, 0. And then we're also going to need to keep track of which lines are black. So we'll say black points. Actually, I like black tiles. That's going to be a set. Okay. So if dir is equal to west, then we'll say x plus equals 1, y minus equals 1. So we basically move up 1 in the x and down 1 in the y. And then else if dir is equal to east, the opposite. So x minus equals 1 and y plus equals 1. Else if dir is equal to northwest, then we will say x plus equals 1, z minus equals 1, else if dir is equal to southeast, the opposite, x minus equals 1, and z plus equals 1, else if dir is equal to, and what is wrong with this? Okay, else if dir is equal to northeast, then that'll be y plus equals 1, z minus equals 1, and else if dir is equal to southwest, then we can say y minus equals 1 and z plus equals 1. So I think that'll work because this will be pretty consistent and it'll allow us to move around the hex grid. So we comment that up. We'll say xy axis. Oops. XZ axis. And then we also have the YZ axis. And at the very end, finally, black tiles dot add X, Y, Z. So that'll go through. And actually, you know what? We do not want this. We're going to say if X, Y, Z is already, if X, Y, Z is already in black tiles dot remove. Because if it's already a black and we landed on it again, we want to flip it over to white. X, Y, Z. Else, and this X, Y, Z should be up here. Don't want to reset that each time. Else, black tiles dot add X, Y, Z, and then finally at the end, how many tiles are black after we've gone through every direction. So if we go ahead and run that, 434. Let's go ahead and try that. Awesome. There's the answer for part 1. So what do we got for part 2? The floor in the lobby is meant to be a living art exhibit. Every day, the tiles are all flipped according to the following rules. Black tile, any black tile with 0 or more than 2 black tiles immediately adjacent is flipped to white. Any white tile with exactly 2 black tiles immediately adjacent is flipped to black. Here, the tiles are immediately adjacent if it's just touching the tile in question. Every tile flips simultaneously. After this process 100 times, how many black tiles will be facing up? Okay, so let's go ahead and say for part 2, the first thing we need to do is be able to get the adjacent count. Get adjacent count of a tile. So how many? So we're going to return how many tiles adjacent to this tile. How many tiles adjacent to this tile are black? So we're going to say X, Y, Z is equal to tile, and then count is equal to 0, and then for I, J, K, in, and basically we need to take each of these, so to travel once in each direction to check that adjacent tile. So we'll say for, like for example, this first one, it would be 1, -1, 0. 1, -1, 0. For example, and then this one would be -1, 1, 0, 1, 0, -1, -1, 0, 1, 0, 1, -1, and 0, -1, 1, and so on. So let me type those in real quick. Alrighty, so now that we've got all those typed in, we're going to say if X plus J, comma, Y plus, oh wait, this should be X plus I, comma, X plus Z, X plus J, and then Z plus K in black tiles, count plus equals 1. So given a point and some offset from a point, does the point plus its offset, which just gives us an adjacent tile, if that offset point is in black tiles, and count plus equals 1. And then finally at the end, return count. Okay, and then we're going to say for blank in range 100, we're doing 100 rounds. Then we'll say new black tiles is equal to set And then we'll also have a set called adjacent tiles is equal to set. So now we'll go ahead and get all the adjacent tiles. So find all adjacent tiles. So we're going to say for X, Y, Z in black tiles. And then using the same loop from before, we can get all of the adjacent tiles to this. So then we will say black tiles or adjacent tiles dot append X plus I, comma, Y plus J, comma, Z plus K. Okay, so now we've collected all the adjacent tiles. Now find all of the black tiles that need to be flipped. So now we'll find all the black tiles that need to be flipped. So once again for X, Y, Z in black, and I guess we don't need to have a redundant loop, so we could add this up here. Count is equal to, I'll say count is equal to get adjacent count of X, Y, Z, and then if count is equal to, and what are the rules here? So any black tile with 0 or more than 2 black tiles immediately adjacent is flipped to white. So if it has 1 tile or 2 tiles adjacent, then it will stay black. It will stay black. So if count is equal to 1 or count is equal to 2, stay black. New black tiles dot add X, Y, Z. So for every black tile, if its adjacent count is 1 or 2, then add it, and then add all of its adjacent tiles to adjacent tiles. So now we will check adjacent tiles. So for X, we're going to change this comment to find the adjacent tiles that should be flipped. For X, Y, Z in adjacent tiles, count is equal to get adjacent count X, Y, Z, and then if X, Y, Z in black tiles and count is equal to 1 or count is equal to 2, new black tiles dot add X, Y, Z, and then we can say else if X, Y, Z not in black tiles and count, and what does it say on that? So if a white tile has exactly 2 black tiles, then it's flipped to black. So if count is equal to 2, then also new black tiles dot add X, Y, Z, and then finally black tiles is equal to new black tiles. And repeat that 100 times, and then print the length of black tiles, and that should give us our answer. And of course, up here, sets should say add and not append, silly me. After that runs for a moment, 3955. Let's go ahead and try that out. And there's the answer for part 2. So if you like this video, please drop a like down below. Have a great Christmas Eve, and I'll see you tomorrow for the final day.